Hello dear students, today we are going to discuss about critical angle total internal reflection in optics. What is critical angle? What is total internal reflection? In the previous sections we would have studied about the refraction of light radiation. When light travels from one medium to another medium, it bends towards or away from the normal depending upon the passage of light from one medium to another medium. This is the basic idea. When light travels from rarer medium to denser medium, it bends towards the normal. Whereas, if the reverse thing happens, when light travels from denser to rarer medium, the light ray bends away from the normal. So, when a light radiation passes from a denser medium, let us say this is N1 and this is N2. What does this notation means? N stands for refractive index of the medium. So N1 is the refractive index of denser medium. I call this as denser medium, and N2 is rarer medium. If light travels from, this is the normal drawn. If light travels from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. If you calculate the angle of incidence is I, if mark the angle of incidence is I, and if the angle of refraction is taken R, you can see the angle of refraction is greater than the corresponding angle of incidence. Angle of refraction is greater than the corresponding angle of incidence. If I is 30 degree, for 30 degree, R would be greater than 30 degree, let us say 45 or 50 or so. Fine. As you know, this is the incident ray. This one is the refracted ray. Now, what you are asked to do is, you increase the angle of incidence. What will happen? The angle of refraction also increases. This is for the second position. As the angle of incidence is increased further, the angle of refraction is also increased further and further, and it will bend away from the normal further and further. For one particular value of angle of incidence, the refracted ray grazes the boundary separating the two media or it makes an angle of refraction which is equal to 90 degree. This happens for one particular value of angle of incidence. I could call this angle of incidence as critical angle. I equals IC. If the angle of incidence is equal to critical angle is a particular angle which is taken as the reference, below which there will be refraction, above which there will be no refraction. So a refracted ray is not possible in the rarer medium when the angle of incidence is equal to critical angle. So what will happen? The refracted ray will graze the surface. It will touch the surface and travel parallel to the surface. The angle of incidence for which the angle of refraction is 90 degree, or the refracted ray grazes the boundary separating the two media, is called the critical angle. So, at what angle this particular action is taking place, that angle is called the critical angle. I could say if critical angle is 45 degree, or if the angle of incidence is 45 degree, for 45 degree angle of incidence in the denser medium, the refracted ray is grazing the boundary separating two media. Then for the denser medium, the critical angle is 45 degree. The critical angle is 45 degree. As the angle of incidence is increased beyond or above this critical angle, what will happen? A refracted ray is not possible in the rarer medium. Then what will happen? The ray incident on the surface will get reflected back into the same denser medium itself. We used to call it as total internal reflection. If the angle of incidence is greater than the critical angle, I am increasing the angle greater than critical angle. See this one? This double line. This I is greater than IC. Now, this is the condition. What will happen? The ray is getting reflected back into the denser medium itself. So, R, angle of reflection, is equal to I. It is no longer refraction. It becomes reflection. So, light is incident from a denser medium and is refracted out in a rarer medium. As we saw, angle of incidence is lesser, angle of refraction is greater because the refracted ray will bend away from the normal. I am increasing the angle of incidence, the refracted ray will also bend away from the normal, which means the angle of refraction increases further and further. For one particular angle of incidence, the refracted ray grazes the surface. Grazes, grazes the surface, which means it touches the surface and travels parallel to the surface or the boundary separating the two media. And then that particular angle is called critical angle. The angle of incidence for which the refracted ray grazes the boundary separating the two media is called the critical angle. Now, if the angle of incidence is increased beyond the critical angle, what will happen? There will be no refracted ray possible in the rarer medium. Then what happens here? The incident ray will be reflected completely back into the denser medium. This action is called total internal reflection. So, in order to get total internal reflection, we need two conditions. One, light must travel from denser medium to rarer medium. Light must travel from denser to rarer medium. Second condition is that the angle of incidence I must be greater than the critical angle. If these two conditions are satisfied, we can get total internal reflection. So what are the conditions required? Light must travel from denser medium to rarer medium. Second condition is that the angle of incidence of the light in the denser medium must be greater than the critical angle. Where from the light radiation is incident? In the denser medium. Where it is emerging out? In the rarer medium. For total internal reflection to take place, the angle of incidence I must be greater than the critical angle. If this condition is satisfied, then you will get total internal reflection. So, in order to have total internal reflection, we need two conditions. Two conditions must be satisfied. One, light must travel from denser medium to rarer medium. Second one, the angle of incidence I must be greater than the critical angle. So, when total internal reflection will take place? When the light radiation incident from the denser medium on the boundary is greater than the critical angle. If I is greater than critical angle, then there will be no refracted ray. There is only a reflected ray possible. So the light radiation will travel back into the same denser medium itself. We used to call it total internal reflection. These two conditions must be satisfied. Now, by Snell's law, product form of Snell's law, by product form of Snell's law, you can write N1 sin I is equal to N2 sin R. This is the product form of Snell's law. I can say here, first medium, N1 is the denser medium, N2 is the rarer medium. If the rarer medium is taken as air medium, then I can write N2 is equal to 1 because the refractive index of air is 1. And for the denser medium, the refractive index N1 can be assumed as N. N1 can be assumed as N. If you substitute N1 as N and N2 as 1, and then the angle of incidence I is equal to critical angle IC. If the angle of incidence is equal to critical angle IC, the angle of refraction is 90 degree. If this condition is substituted here, then you will get the condition for total internal reflection or expression which relates the critical angle and the refractive index of the denser medium. So, in the product form of Snell's law, N1 sin I is equal to N2 sin R, where N1 is the refractive index of the second medium. I am assuming the second medium to be a rarer medium, which is air medium. For air medium, refractive index is 1. So, I have taken N2 as 1. Then, the first medium is denser medium. Denser medium whose refractive index N1 is equal to N. I am taking it as N. Then, the condition what I am taking here is the critical angle. When the angle of incidence I is equal to the critical angle of refraction is equal to 90 degree. If I substitute all these conditions, then I will get the relation connecting refractive index of the medium and the critical angle. So I can substitute here in this expression. N1 is taken as N, angle of incidence is IC, so I can write sine of IC, and N2 is taken as 1, and then angle of refraction is 90. What is sine 90? 1. So N into sine IC is equal to 1. Sine IC is equal to 1 divided by N. Or IC is equal to sine inverse of 1 by N. So the relation connecting critical angle and the refractive index of the denser medium is this one. IC equals sine inverse of N. So the refractive index of the medium or the critical angle are inversely proportional. The dependence, critical angle, varies inversely with the refractive index of the medium. As the refractive index of the medium goes on increasing, then the value of critical angle goes on decreasing. They are inversely proportional. So I could say the critical angle varies with the refractive index of the medium. I can go with some example here. For example, if I consider glass has a refractive index 1.5. So the critical angle for glass is IC equals sine inverse of 1 divided by 1.5, which is sine inverse of 2 by 3, which is almost 41.8 degree. So the critical angle for glass is 41.8 degree. For water, it is 1.3, refractive index is 1.3. So critical angle IC is equal to sine inverse of 1 divided by 1.3, which is 48.6 degree. You just look at the case here. Refractive index is more, critical angle is less. Refractive index is less, critical angle is becoming more. So I can say the value of refractive index and critical angle varies inversely. One, as the refractive index increases, critical angle decreases. As the refractive index decreases, critical angle increases. There are various substances whose refractive indices and their critical angles are mentioned in a table in your textbook. You can just check it out so that you can have an idea how the variation of refractive index and critical angle is taking place. We shall now discuss about the effects due to total internal reflection. The effects are these are the important applications of total internal reflection which we are going to discuss. One is glittering of diamond. You might have seen the dazzling light coming out of diamond. How it happens? It is due to the total internal reflection taking place inside diamond. The refractive index of diamond is 2.417, which is greater than the refractive index of glass, which is 1.5. As the refractive index of diamond is 2.417 and the glass whose refractive index is 1.5, the corresponding value of the critical angle can be taken here. The critical angle for this diamond is around 24.4 degree, and for glass you may get some value around 40 degree. So we can say the critical angle for diamond is less than critical angle for glass. Critical angle for diamond is less than the critical angle for glass. So what is the meaning for this? What is the idea behind the variation in the value of critical angle? Simply we can say the critical angle for diamond is 24.4 degree. So a skilled diamond cutter can cut the diamond in such a way that he can able to use a wide range of angle from 24.4 degree to 90 degree. What is the meaning for that? So the angle of critical angle is very small for diamond. So from 24.4 degree to 90 degree, you can make the light to incident on the diamond to obtain total internal reflection. Whatever the angle of incidence lying between 24.4 degree to 90 degree, you will be getting total internal reflection. So any light which is incident into the diamond will be coming out of diamond by undergoing total internal reflection. So when light enters from one face of diamond, it will undergo total internal reflection from many faces of diamond and will come out. So whatever the direction from light is incident inside diamond, then if the diamond cutter cuts the faces of diamond in such a way that the angle of incidence is ensured to lie between 24.4 degree to 90 degree, then the light radiations will all undergo total internal reflection inside diamond and will emerge out. At a time, simultaneously, if light is coming out of diamond, then it will shine, it will glitter. So the glittering of diamond happens only due to total internal reflection. How? Because of its refractive index. As you know, diamond is said to have a greater value of refractive index. It is much denser when compared to glass. As the density is more, the critical angle is less. Critical angle is around 24.4 degree. I am approximating the value of critical angle for glass as 40 degree. There are different glasses whose refractive index range from 38 degree around to 40 to 43 degree or so. So the critical angle ranges from 24.4 degree for a diamond, and for glass it is 40 degree. So if light is made to incident on the diamond faces, it can be made to incident between 24.4 degree to 90 degree. So if a diamond cutter, a skilled diamond cutter cuts diamond in such a way that the light which is incident on diamond is lying between this 24.4 degree to 90 degree, all the light entering into diamond will be emerging out after getting totally internally reflected from many faces of the diamond, so that diamond shines. I can just show it with a simple diagram. Actually, there is a separate course for the people who are cutting diamond. So, for this particular phase, this is the normal. I can say this is 24.4 degree. We can say this is the critical angle. What should happen? Light which is entering the surface must incident at an angle greater than the critical angle. If light enters from rarer to denser medium, it will bend towards the normal, right? So it bends towards the normal. If it is incident on this particular point or incident at the normal to the surface, I have shown that this is the critical angle. Now the light is incident which is greater than the critical angle. I can show I is greater than IC. So what happens? It will just reflect back like this. Angle of incidence and angle of reflection must be equal. Then it will fall like this and will emerge out. In this way, it will fall here and will emerge out. So incident light will be emerging out. In the same way, if light is incident on another direction, that will incident on this phase and then get reflected over here and then it will be emerging out. So the simultaneous reflections which are taking place at many phases of the diamond emerges out. It appears to glitter. It appears to shine. So the glittering of diamond is due to the effect of total internal reflection. We shall see the second effect, mirage and looming. These two effects happens because of total internal reflection. First we shall speak about mirage. Consider the ground surface. This is earth. Above earth there is the atmosphere. I can divide the atmosphere into different layers of air. I can say during hot sunny day, the layer of air which is very close to the earth's surface will be hot, and as you move above the earth's surface, the temperature of air decreases. Temperature and density are inversely proportional. More the temperature is, less the density of air is. How? As the temperature increases, the distance between the air molecules will be taken further apart. So the density of air molecules or density of air decreases. So this region of air is less denser. So I can write this is less denser. As you move above the earth's surface, you will be increasing, or the air whose density will be keep on increasing. So density of air increases over here. Right from the ground surface to a higher altitude, the density of air keeps on increasing. As the density increases, density and refractive index are directly proportional in this particular case in optics. I am specifying this here because while you speak about the electron density, I am speaking about the air density. If you go with the electron density, when you speak about ionosphere, the entire idea will change. in communication devices and electronics, you will be discussing the relation between density and refractive index as inversely proportional. That's why I am specifically saying in optics, especially while speaking about the density of air medium with density of medium with respect to refractive index, if density is more, refractive index is more. Density is less, refractive index is less. Here, air is less denser, so refractive index is less. Here, density is more, so refractive index n is more. So you just look at the case here, more density, more refractive index, then refractive index decreases here, refractive index further decreases here. So if you consider a tall object like a tree or so, which is there on the surface of earth, a tall object like tree, light from tree travels from denser medium to rarer medium. So like this. Light ray will travel along this direction. As the light travels from the tall object, it travels through denser medium and falls on a normal of a particular boundary. It bends away from the normal. Once again it falls on the boundary, it bends away from the normal. I am considering this portion of air where the angle of incidence I is greater than the critical angle. This happens. If the angle of incidence is greater than the critical angle, at that particular point the light ray once again travel back into the same medium itself. So total internal reflection takes place, light ray travel along this direction. So light from tall object travels to different layers of earth atmosphere, and then when it reaches the bottom layer of air, which is close to the earth's surface, it will undergo total internal reflection when the angle of incidence is greater than the critical angle for this particular medium. Then it will be reflecting back and reach the height. So it will give an effect in such a way that the object, there is some object which is lying below the ground from where the light radiation is coming. It gives an image in such a way. This is the object and this is the image. But you will get appearance as if an object is lying below the earth's surface. And due to the shaky nature of air, the same object will appear in such a way that there is a light coming from tall object and it gets reflected from a water surface or a wet surface. So that what will happen, you will be getting a shaky nature of the image from the ground, as if it is coming beneath the ground or below the ground. But where the object is actually a tall tree or tall building is there. But you seem or you will get an illusion as if the object is there below the earth's surface and from where the light radiation is coming. And due to the shaky nature of air, you will get an appearance as if there is a pool of water or a wet surface from where light radiation is getting reflected. But it is not actually happening so. It happens because of total internal reflection. This is how the total internal reflection takes place. Light is incident at a particular layer, it will get bent away from the normal. So this angle of incidence, this is the angle of refraction, this will be more than this one. And the same angle will be here. So as the angle of incidence is increased, angle of refraction will also get increased. This is how total internal reflection takes place at different layers of air. So finally, you will get an appearance or an illusion as there is an object which is lying below the earth and it is getting or it is giving an appearance to our human eye. Or otherwise, I could say a tall object from where light radiation is passing through is getting reflected from a wet surface or from a pool of water. Why? It is due to the shaky nature of the air layer. So you will get an image in such a way which will be just wavering around over the surface of the ground. You might have seen this kind of mirages on the tarry roads during hot sunny day. If you travel through a vehicle, you can see some objects which will be getting reflected from the tarry road, and you will be getting an image as if there is a pool of water lying on the surface of the road. But as you go close to the road, you won't see anything. You won't see anything because it is an illusion. It happens because of total internal reflection. The reverse effect is looming. Reverse effect is looming. Where it will happen? It will happen in cold countries. It will happen where there are glaciers, where there are frozen lakes, where there is too cold climatic condition. There you can see this kind of looming. What happens here? The same Earth surface. We can divide the layer of atmosphere into different layers of air. An object is there on the ground. This is human eye. Light will be traveling like this. Now, the air region very close to the ground will have a greater value of refract index than the refract index at higher altitudes. Why? Because the surface of the ground is too chill, too cold, so the temperature is less. So refract index is more. As you go above the Earth's surface, the temperature increases, so refract index decreases. As I mentioned earlier, refract index and temperature are inversely proportional. If refract index is more, then we can say the medium is denser. So the air layer which is close to the ground is denser. Air layer at higher altitudes is considered rarer. So what will happen? It will get reflected or refracted to a greater range of angle, and then once again total internal reflection sort of thing will take place. At this particular region, light will get reflected back like this. So we can say here, light travels like this and reaches the human eye. And this gives appearance as if there is a object which is lying exactly above the original object, and it is giving you a vision or an illusion that there is somewhere an inverted object which is present at higher altitudes, and we are seeing that object, but it is not actually so. What exactly is? There will be some other object which will be lying on the ground, which will give an illusion due to this total internal reflection. So what happens is, in case of mirages, light travels from denser medium to rarer medium, and when it reaches close to the ground, it will get reflected once again back. So it will give you an appearance that the taller objects will appear to come from the ground. The image shows such a behavior that light comes from the ground. So an inverted image will be seen from the ground. Due to the shaky nature of air, you will be getting a wavery nature of the image of the taller objects. So we used to call it mirage. In looming, the reverse is happening. What happens is, an object will be there on the ground. The surface close to the air medium close to the ground is said to be denser, and air medium at higher altitude is said to be rarer. So what happens is that light travels from the denser medium to rarer medium. At each and every layer of air, it will get refracted out. At one particular point, it will get totally internally reflected and will reach the human eye. Then this gives the appearance of the object as if it comes from certain height. So the image of the object will exist exactly above the object. So this is called looming. This happens in the cold countries or colder regions. Fine. We shall now speak about the next effect, which is nothing but the prisms which are using this critical angle and total internal reflection. The example application is prism. Prisms also use total internal reflections. Prisms can be designed to reflect the light radiations through an angle of 90 degree or 180 degree. Even without changing the size of the object, we can obtain an inverted image using prisms. It must be designed in such a way. And the material which are used to construct this kind of prisms must possess an critical angle which is less than 45 degree. So to construct prisms, the material should possess a value of refractive index which will produce the critical angle whose value is less than 45 degree. Ground glass and flint glass have their critical angles which is less than 45 degree. So the prisms are mainly made of ground glass and flint glass. I can show you the diagram here. This is a right angle prism. This angle is 90 degree, this angle is 45 degree, this angle is also 45 degree. If light radiation is made to fall on the prism, this is the object. Let me mark this as AB. After reflection, it will emerge out. So it can be made to reflect the light at an angle of 90 degree. Why? This is the angle of incidence 45 degree. I told you the condition, the critical angle must be less than 45 degree. So if crown glass or flint glass have a critical angle less than 45 degree, then I am making the light radiation to incident at an angle of 45 degree, which is more than the critical angle. So it will get totally internally reflected. So image will be obtained like this. So where it is? It will be inverted. So this is A prime, B prime. So the light radiation is reflected through an angle of 90 degree on the basis of total internal reflection. And the second condition is that you can make the light radiation to get reflected at an angle of 180 degree. This is 45. This angle is also 45. This is 90 degree. Then when parallel light rays are falling on this prism faces, then it will come out. This is AB, then this one is A prime, B prime. So this one, once again, the same condition. Angle of incidence is 45 degree. In these two cases, I told you the critical angle must be less than 45 degree. Less than 45 degree. Now the light is made to incident at an angle of 45 degree, which is greater than the critical angle. So what will happen? Total internal reflection will take place. So the materials that are chosen to construct prisms are crown glass and flint glass, because these materials have their refractive indexes which will provide you a critical angle which is less than 45 degree. So you are getting image which is getting reflected through an angle of 180 degree. Even you can construct prisms which will produce a image which is same size as that of the object. So I can say two parallel rays are incident on one face. After reflection, they will travel like this. See this one. If this is the object, let us say AB, then this ray is going over here. So it will get inverted A prime, B prime. But the size of the image is same as that of the object. This all happens due to total internal reflection. Fine. So what is total internal reflection? When light radiation is made to travel from denser to rarer medium, the light gets totally internally reflected into the same denser medium itself. When it will happen? When it satisfies two conditions. One, light must travel from denser to rarer medium. Second one, the angle of incidence I must be greater than the critical angle. What is critical angle? The angle of incidence for which the angle of refraction is 90 degree, or the refracted ray grazes the boundary separating the two media. This is called the critical angle. If this is known, if this is clear, then understanding the effects of this total internal reflection is also much clearer. What is the relation connecting critical angle and the refractive index of the medium? You can simply say IC equals sine inverse of 1 by m. Sine inverse of 1 by m. Where n is the refractive index of the denser medium. N is the refractive index of denser medium. IC is the corresponding critical angle in the denser medium. Critical angle and the refractive index varies inversely. Greater the refractive index, lesser is the critical angle. Lesser the refractive index, greater the critical angle. This idea is much simple. Let us go through it. We shall see in the next class. Thank you.